Okay, y'all. I've been kicked out of my room, and the room that they've moved me into, the projector is not turning on. And so I am going to quickly record notes 35 for y'all. And for those of you that are remote, if you have questions, I will leave the Google Meet open. By all means, ask. But I have to resort to using a dry erase board because the projector is not functioning at all. But at least I can record this and upload it into Canvas via my YouTube account. But we are going to be doing what we did last week, the mole-gram conversion using a periodic table. So you need a periodic table to be able to do what we're doing, really everything for the rest of the year. But we're going to be converting between the grams using the molar mass from the periodic table to a certain number of moles of a substance or vice versa. Now for the opener, just to try to push this along, because I have to record this in 20 minutes before fourth period starts, we want to know what the difference is between a gram atomic mass, a gram formula mass, and a gram molecular mass. They're all done the same way. You use the periodic table. You're using that atomic mass unit, the bottom number inside the periodic table block. But the differences between these, it's not that they're necessarily done differently. It's the fact that a gram atomic mass is for an element, which means no subscript. A gram formula mass would be if it's an ionic compound, which is a metal first, normally, except for ammonium ion, and then a non-metal. And then gram molecular mass would be a covalent or a molecular compound where it's built of nothing but non-metals. Hopefully I will be back in my room and I will be re-recording this from my room, being able to actually take my time going through this. But if not, this is unfortunately what I'm left with trying to do to make sure that everybody has equal opportunity to get the information. For notes 35, this is what we were doing last week. You're taking that molar mass and you're converting between grams and moles. Now, just as a review, and this is one that we've done before, I want to know how many meters are equal to 680.2 inches. These conversion crosses, this is how I normally work my problems. If you have one up and down line, that's indicative of a one-step problem. If you would have another up and down line, and then this would be extended, that would be indicative of a two-step problem. But you know how many steps you have because you have a starting substance, and in this case is 680.2 inches, and your unit that you're starting in is not what you want it to be. Now, normally your starting unit is over 1. So for those of you that don't want to leave an empty hole, you're going to put a number 1 down here. But in order to cancel out or to divide out, we're going to bring the starting unit, which is an inch, down, and we're going to do what is called a conversion. And in this case, I do have the ability to go between meters and inches directly. If I didn't, then I might have to have another step in order to convert. But because I gave you the fact that 1 meter was equal to 39.37 inches, the meter gets a 1, okay, and then the inch gets 39.37. The thing that I like about stoichiometry is you know that you've set it up the right way because everything cancels except for the unit that you're trying to change it into. And you don't have to either multiply or divide by 1. These conversion crosses are set up that everything on the top is a numerator, which is multiplied. Anything on the bottom is a denominator, which is multiplied, but then you would take the top value and divide it by the bottom value. Now, this is a one step. It's pretty straightforward, but parentheses are your friend when we get into multi-step conversion problems. And we will do that on Wednesday. And like I said, hopefully I will be in my room. But this essentially translates to 680.2, technically times 1 divided by 1, but I canceled them out. That divided by 39.37. And I end up getting 17.28 meters. Now, I know how many numbers should be in my answer because it should match the number of significant digits in what you started with. And this has 1, 2, yes, the 0 counts, 3, 4 numbers. 17.28 is also 4 numbers. You do need to remember your significant digits, and the only value that may not count is going to be that infamous number 0. But this one does count because it's sandwiched in between the 8 and the 2, plus there's a decimal in the number as well. I like using the railroad tracks or the fence post or the goal post. I've heard this called all different kinds of things, but what you're starting with is going to go in the starting block, which is the top left, which is normally over 1. Its unit, not the number, its unit. So like on the previous one was an inch, not the 680 number, but the inch came down. And then I could change it into the meter because I had a conversion factor to go between meters and inches on the previous example. If you want to set this up as a factor, you can also, where your starting substance would be over 1, you would put that in parentheses, times, and then you would have its unit would still drop and you would convert. But once again, these would come from a conversion factor. This is the same as the top one. It just throws everything together on one nice long line. And once again, this line is a giant division line. You would multiply anything on the top. You would multiply anything on the bottom, but you would do top divided by bottom. It's the same thing. I was taught this way with the parentheses, but most of my students in the years that I've taught chemistry, they actually prefer this railroad or this fence post. Your answer should have the same number of sig figs as whatever you start with. If you start with 2 sig figs, your answer should have 2 sig figs. The sample problem that we did with the inches and the meters had 4 sig figs, so my answer had 4 sig figs. Your molar mass, you need 2 numbers after the decimal. I don't care if it's a 0. I want 2 numbers after the decimal. Molar mass does not control how many sig figs your answer has. Your answer is controlled solely by your starting substance significant figure value. And it is way more important to make sure that you're putting your units in first before you drop in the numbers. Your units tell you what number goes with what. I don't care if you're starting in inches, meters, moles, grams, whatever you start with, you should immediately pull that unit over and down 1, and then you convert. If you have to go further, you would pull that conversion unit over and down 1, and then you would convert. 2 conversion factors for the molar masses of the following. Salts, infamous sodium chloride. Sodium has 1, chlorine has 1. We don't write subscripts meaning 1. I am pulling the 22.99 straight off of the periodic table. If you find sodium on the periodic table and look below it, I am rounding to 2 numbers after the decimal. Chlorine rounds to 35.45. This is exactly what we were doing last week. When you add these 2 numbers together, that's what gives me the fact that 1 mole of salt, or sodium chloride, is equal to 58.44 grams of sodium chloride. Or you could say that the molar mass, or the formula mass specifically for salt, is 58.44 grams per mole. They all mean exactly the same thing. You can write it both ways. You are taking 2 different units that mean the same representative value, and anything divided by itself is 1. That's like saying you take 1 foot and divide it by 12 inches. They both mean the same length. The unit, depending on how large or how small it is going to control how big or how small the numerical value is that goes with it. But in this case, 1 mole of salt is 58.44 grams. They are equal measures of each other, and anything divided by itself is 1. So you can flip-flop these on top of each other, and you're actually not really changing the math. This is why I say putting the unit in the right spot is more important. You come back and fill in the numbers, because in this case, the mole would get a 1, no matter if it's top or bottom, and the gram would get 58.44, no matter if it's top or bottom. barium hydroxide. I have one barium. Each barium has a mass of 100, or I apologize, an atomic mass unit of 137.33, but there's only one of them. I have 2 oxygens and I have 2 hydrogens. Each oxygen has a mass of 16.00, which ends up being 32.00 atomic mass units, which we're going to change to grams. I have 2 hydrogens, of which each has an atomic mass unit of 1.01 times 2 is 2.02 atomic mass units. And when you add them all together, when you replace AMU with G, this tells you that the molar mass of barium hydroxide, which is a gram formula mass because this is ionic, is 171.35 grams. That is equal to 1 mole of barium hydroxide. So my conversion factors, these are the same thing. 1 mole of barium hydroxide is equal to 171.35 grams of barium hydroxide. 1 mole of barium hydroxide is equal to 171.35 grams of barium hydroxide. You can write them either way. We'll do 2 sample problems real quick. I have a starting substance of 2.5 moles of salt. I am going to drop that into this top left-hand block. I've already calculated that a mole of salt is 58.44 grams. I've already done that. And I'm going to put it over 1. I need to bring its unit down, not the number, but moles of sodium chloride are going to come down. And I'm going to change it to grams of sodium chloride using the molar mass of salt, where the mole gets a 1 and the gram gets the 58.44. They're equal to each other. I can, if I had started with grams and gone to moles, then this side would have been flip-flopped upside down. I know I can cancel out moles, do not need to divide by 1. And this becomes a multiplication problem. And 2.5 times 58.44, I am going to round it to 2 significant, not 4, 2 significant digits. So the 6 makes the 4 round up to a 5, and it's 150 grams of sodium chloride. I have one more sample problem. And I'm going to upload this just in case I can't get back into my room, which is not looking like that's going to happen now because the projector does not work in this room. 125 grams of barium hydroxide to moles. All right, well, I'm not starting in moles, I'm starting in grams. But this 3 significant digit value is going to be my starting block, which will be over 1. I already calculated the molar mass of barium hydroxide of 171.35 grams. This was done previously. The grams of barium hydroxide is going to drop over and down 1. And I'm going to change it to moles using the molar mass or the gram formula mass, because this is ionic, of barium hydroxide, where the mole gets a 1 and the gram gets 171.35. I'm going to cancel out grams. I do not need to multiply or divide. I guess I animated that out of turn. Either multiply or divide by 1. And this becomes a division problem. 125 divided by 171.35, and I'm going to round it to 3 significant digits. So 1, 2, 3. The 5 is enough to round the 9 up, which will round the 2 up, but won't affect the 7. So the correct answer for this is 0.730 moles of barium hydroxide. There was not another slide. For those of you that are remote, and my in-person students too, I apologize. Like I said, I was kicked out of my room. The projector in this room does not work. I do have a dry erase marker. I'm going to ask everybody to go ahead and follow along with this first to be able to answer the notes. And then if you have questions, then we will, let's see, the assignment is already printed off. It is notes 35. This is the assignment. So you're going to be doing sodium hydroxide, calcium chloride, And then the propane and the aluminum phosphate is the assignment for today. Now, tomorrow is a work day. Let's hope I'm in my room. If you have problems, questions, concerns, I don't know how you calculated the mass. I don't know how to set up this fence post. How did you know when to cancel? How did you know when to multiply or divide? That is what tomorrow is for. I'm very glad that I built in a work day tomorrow with all of the events that have just happened. I am going to go ahead and stop the recording. And like I said, if we have any questions, concerns, especially those of you that are remote, I'm not going to be right next to my computer like normal. I may not hear you ding in, but if you have any problems, please let me know.